And welcome everybody. Hey, I am so glad that you are here. We're just a few seconds before the top of the hour Pacific time. So I am going to just say hello to everybody who's gotten here early. I appreciate it. How are you? How's your day? I had something happen today I want to share with you. And then I have a couple things I will talk about. And then we'll go right into interpreting an IP routing table. My car. I have a little teeny electric car. I bought it used. I love it. It's one of those things I really get a lot of pleasure about. And a couple days ago, a little light came on saying, "Be sure to wear your safety belt because the driver's side airbag has an alert. Seems like it's not working." So I thought, oh no. I took it in to the dealership. So this morning I got up at my normal time, 10 minutes to 6, did a quick cardio workout, drove it to the dealership, dropped it off. And he says, with labor and everything, this is going to be, and he gave me a price. And I said, I was like, what? My first car didn't cost that much. My first 2 topics, and I'd like your choice of what you would like to see next week. So sometime between now and the end of the stream, type in what you'd like, and I've got 2 choices for you to choose from. OSPF, or anything related to OSPF, Open Shortest Path First, which is a pretty nifty link state routing protocol, one of my favorites, or router on a stick. So let me know which one of those, if either, would be most interesting to you, and I'll go ahead and prepare that for next week, same bat time, same bat channel. Also, I wanted to chat with you about peer reviews. You might say, Keith, what are peer reviews? At CBT Nuggets, we do peer reviews with another trainer. They look at our content, we look at their content, and make sure it's acceptable. Not just acceptable, but the bar is pretty high. We want to make sure our content's really engaging, useful, and everything else. And I got to tell you, I'm working on some DevNet content. The CCNA content is just about wrapped up as well. And when you can have your peers watching your content, and we do it over webcam, and so I'm watching their face as they're going through the content, and then they're saying, oh, that's how that works. It is so amazing. And I've also done that with my son. I have a son who, he's 21. His name's Riley. And I hire him to come in, look at my videos, and actually go through the hands-on labs that we're providing at CBT Nuggets, just to make sure that these are solid and ready. Because I remember back in the, I won't say how, maybe back in the late 80s, that's a long time ago, in a galaxy far away, when I was first working with Novell, way back then, I learned about how it all worked, right? The protocol stack and everything else. And I still remember, this is a feeling that's going to be common if you're just getting into IT and just getting into networking, when they call on you as the expert. And I had a company call me and say, we can't print. So I went in and like, oh no, they can't print. Oh no, they can't print. So what happened though, because I had practiced and I had studied with, at that time it was Novell Networking, I basically went in, I said, okay, let me take a look. I logged in, print queue, printer, driver. Oh, here's the group membership that was off. Boom, fixed it. I was almost surprised that I could just solve it so darn quick. But it was because I had spent a lot of time studying and preparing. So in the real world, when we get to the field and we're working with things like first hop redundancy protocols, or working with dynamic routing protocols like OSPF, or we're working with a troubleshooting routing or switching or whatever it is, it's going to be amazing to you if you join us in this journey of studying and practicing, that when it comes down to actually doing it, you'll be much quicker at identifying problems and solving them and troubleshooting issues because you understand how the pieces all fit together. So I'm very excited about, I'm excited about a lot of things. I'm super excited about the new CCNA content that we're creating. So at CBT, what we do is we take, also a question often comes up, Keith, what's CBT Nuggets? What is that? CBT is an acronym for computer-based training. And a long time ago, when online or digital training was first out, so they called it computer-based training. So CBT Nuggets is about taking available training, whether it's offline or online, on your mobile device or on your computer, and making really concise topics, like nuggets, like gems, like the juice of what you want to learn, and make it very effective. And it just so happens that the team at CBT is corny enough and, real enough to expose ourselves enough in the videos that we make it entertaining, and it feels like just like right now with you and I talking with each other. So anyway, I look forward to seeing you in those videos. So in today's live stream on the topic of routing and switching, and on the topic of, I'm so excited about everything. On the topic of reading a routing table, here's why it's important. when a packet comes into a router, here it comes, that router, when it looks at it, it's going to look at the layer 3 destination IP address. And it's going to say, is this for me? Do I have an IP address that matches that? If the answer is no, it's then going to look at the routing table and see whether or not it has a route for how to forward that packet on its way. And it's sort of like hot potato. What do you mean, like hot potato? Well, routers, IP routers that route IP packets, it's like hot potato. Let's imagine that you and I are playing a game called Hot Potato, and it involves a hot potato. So let's say this fan control is a hot potato. What happens if I toss it over to you and you catch this hot potato in your hands? What are you going to do with that? And the answer is right on. You're going to say, wow, it's a hot potato. Poof, get rid of it. That's what routers do. They take a packet in, they look at the IP address, and they route it or get rid of it as quick as they can based on their routing table. And when that routing table is, what do you call it, messed up or not correct or pointing in the wrong direction or missing a route, that's what causes networks to fail and for the routers not to forward packets. So we create our content in skills, a set of videos that are on one topic. And I have a set. I'd like to share it with you. Let me bring it over the screen. And oh my gosh, our animations are so fun. This is a little, so this is for a review of how networks operate, and it basically goes something like this. When a packet's going through the network, what level of the protocol stack does it have to go through? Well, if it's going through a switch, it'll be processed at the data link layer. If it's going through a router, it'll be the network layer, and so forth and so on. Anyway, I'll put that to the side. So this is a representation of a skill that I've been working on. Actually, it's done. It's got 9 videos. One's an intro, though, and one's a close. So it's got 8 fairly short videos. But check this out. See these little cubes right here? These little cubes represent, there's a lab associated with each one of them. And I feel it's really important, whether it's, if you have your own physical gear, or if you want to use Packet Tracer, which is a great resource, or if you want to use GNS3, or if you want to use Viral or EVNG, or the hands-on labs through somebody else. Getting the practice is really important for that muscle memory. So I would encourage you to get practice wherever you can, and we offer these as part of the new CCNA that's going to be released. I don't know the exact date, but currently it's 2019, and it is the 13th of November, and it'll be released sometime after today. How's that for a loose date? Anyway, most of the a lot of the content is done and just being proofed in final touches. So what I would love to do is, we have a few minutes for this stream, and I think I would love to go ahead and play you a couple of these videos. These are, as of right now, of this live stream, these have not been released to the public. So the only people who have seen these are my peer reviewers at CBT Nuggets, my son Riley, who I watch. And the benefit of me watching him go through it is I'm looking at his face, I'm looking at him doing the labs, and I want to see, because he's 21, he doesn't have an IT background. I want to see whether or not he is able to learn what I'm picking up, what I'm putting down, and also be able to apply that in the labs. And so I'm very, very happy about this. I'm happy to share them with you too. So I'm going to turn the volume up on my external speakers here. They'll be picked up by this microphone for the live stream, and then I'll size it up so we can see it all perfectly as well. So let me start. I think we'll have time. You know what? I'm going to see if I can squeeze in the intro, which is really, really short, and video 2 and video 3. That way we can enjoy them all together. And also in the meantime, I will be looking on the side channel for any questions or comments. And when we come up from after these, we'll take those. So here is the intro video right here. One of the common questions that we're going to ask routers a lot is, why? As in, why did you drop that packet? Or why did you forward it that way, not that way? And we can get those answers with the command show IP route. Now, the better we understand that routing table and determine what the elements mean, the better we're able to understand why the router did what it did. So here's what you and I get to do in this set of videos regarding interpreting the IP routing table, is we're going to break down the routing table step by step to make sure we're clear on each of the components. And that way, when we do a show IP route, we can look at the output and say, oh, I get it, I understand it, that's why. And then we'll finish up this set of videos by applying our skill of interpreting the routing table to identify in a production network why the network as a whole is forwarding traffic the way it is. So we're going to keep this intro really short, and I look forward to seeing you in just a few moments in the very next video. And look how easy that is. So in the player, these will be a nice, beautiful playlist for you. But in Studio here, where I create and I live, I'm going to go ahead and launch them individually for you so we can enjoy them together.
Have you ever had a situation where you heard some information from somebody and then you say, how did you know that? Or where did that information come from? Well, that same type of question is really relevant on a Cisco router as well. As we take a look at the routing table and we ask it, hey, where did you learn that route? Or where did that route come from? We're going to solve that problem and answer that question with the router protocol codes on a Cisco router. Let's take a closer look. So to look at the routing codes to help determine, hey, where did that route come from? Go ahead and log into the lab, and then from DCNUG, we're going to open up MT Putty up in the upper left-hand corner, and let's open up a console to our routers. And let's start with router 1. And to see the routing protocol codes and to answer the question, where did that route come from? All we need to do is a show IP route, just like that. And then I'm going to press enter just a few times until I have at least one OSPF route that's showing up. And you can replicate this right alongside of me in the lab. And when doing a show IP route, the first thing that often hits me is that, man, there's just so much information here. And that's why we're going to break it down just one little step at a time. So in this output of show IP route, on the far left-hand side here, there are some codes. And these codes are explained up here, or they identify what those codes mean. So let's start off with a few that we've seen before, including C. Now, if there's a route, in this case, it's the 1111 network, a 32-bit route. If it says C, that means it is directly connected. What do you mean, Keith? How do we get a directly connected network? Well, it's simple. We take an interface, and we bring it up. We assign an IP address, press enter, and poof. Whatever network that is, the router believes it's directly connected. There is another option or two to get directly connected networks, including static routes that point to an exit interface only, but we'll save that for another discussion. So the primary way is configuring an interface with an IP address, and boom, it's a connected route. Next, let's tackle the S. So we have this default route, and the S here represents that this is a static route. How did you get into the routing table? Somebody configured me. That's what the router would say. It's a static route. And this little star, this little asterisk next to it, that indicates that it's a candidate default. That means, hey, that could be the default route. What do you mean it's the candidate? Well, there may be 4 or 5 or dozens of potential default routes being advertised or communicated to this router. So it puts a little asterisk next to the ones that are a candidate. And not only was it a candidate, this right here implies that it actually won because we have a gateway of last resort. So the routing protocol code of S represents that route was brought into this router as a static route. Next, let's take a look at these 3 routing protocol codes. Actually, it's one code used 3 times. And that R, if we look at the decoder up here on top, represents RIP. RIP is a fairly old dynamic routing protocol. But if this router is running RIP and has learned networks via RIP, the routing protocol code on the far left is going to give the story away and let us know, hey, these routes were learned via RIP. Then going down a little bit further, we've got another directly connected network. Also, if we have an Ethernet interface and we configure an IP address on that interface, in this example it's a 10.1.0. something that we configured with a 24-bit mask, and so the router believes it's directly connected to the 10.1.0 network, it will also create a 32-bit route as an L. And we can look at the L up on top as a local route. Now, that local route being automatically added has not always been the case over the years. But when they added it, they mentioned it's going to help improve the performance of the router by having that local 32-bit route. So when we have Ethernet interfaces, that local route is going to show up next to the actual network that the interface is connected to. In this case, it's gig 00. And then one last one here on this page is O, the routing protocol of O. If we look up here in the decoder, that represents it's an OSPF learned route. So if we wanted to ask the router, hey, how did you learn about the 10.2.0 network? I mean, what was the mechanism? Over here on the left, the routing protocol code says OSPF. And that's a great and easy way to very quickly identify how that route was learned by this router. So in this video on that, we've answered the question, how did you get that route? And by looking at the routing protocol code, it can give it away. It can say it was learned via OSPF with an O, or learned via RIP with an R, or it's directly connected with the C. So that, my friends, is how we could use the routing protocol code to give us inside information on how that route showed up in the routing table. And as we proceed through the routing table, we'll take a look at each of the other components step by step until we have a master picture of how to determine, interpret, and read a routing table. So I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.
All right, and let's do Let's do one more. Should I feel guilty by enjoying watching these? I feel like I could binge watch my own videos. I feel a little guilty about that, but I think, you know what, man, it's on point. So the intention behind the scenes, whenever I make a video, is I have a main topic that I want to communicate, like what I want the learner to get out of it. What, like at the end of the day, if you trade 5 minutes of your life and watch this video, what do you get for it? And I'm very specific in my notes as far as what I want to convey and what I'm going to transfer in the learning process. So it's a two-way street. It's you and I and going through this content together and enjoying it, having a good time. And I've enjoyed creating it. I hope you enjoyed it as well. Let me bring up one more, and that'll be on the network prefix, which is another way of saying the left-hand most side of a network address, and a mask. And I'll bring that up right now.
As you and I issue the command show IP route to look at the IPv4 routing table on a Cisco router, on the far left, it's going to have that routing protocol code. Where did this route come from? Fantastic. And then following that, it's going to have the network as well as its mask. And it's that I'd like to discuss with you, that network and the mask that I'd like to chat with you about right now. So to reinforce this, I would love you to join me in the hands-on lab, and we're on our admin machine, DC NUG, and let's open up MPutty, and let's open up a console to R1. And here on R1, let's look at the routing table. And the command for that, of course, will be show IP route, and then we'll press enter, and that's going to give us one page at a time. And we can just hit spacebar a couple times to go ahead and cycle through all the pages, and let's take a look at the very end. So over here on the left in this column, we have the routing protocol codes, which we covered in the previous video. And then next, we have the actual networks, followed by the masks. And let's talk about that for a moment. Now, fortunately, these are sorted for us these days numerically. So lower numbered networks will be before higher numbered networks, and it's easier to find things. That has not always been the case over the years, but fortunately it is now. And then for each of the networks, we're going to have this entry here. Because 10 is a Class A address, it's going to show us 10.0.0.0 with an 8-bit mask. And then below it, it'll show us the carved out networks and subnetworks that are included in that 10 address space. So even if we don't have any 8-bit masks configured anywhere, because it's a Class A address, it'll show up as this heading in the routing table, and then it'll show us the more detailed routes that we have in our routing table. So in short, this 10 network with an 8-bit mask is not a route. This is just a heading for these networks below that begin with 10. So let's talk about the keyword of network. And I'm also going to use the word street because networks are very much like streets. And we could also use the word prefix because oftentimes we're referring to networks by the name prefix. So whenever you hear the word network or prefix, we're simply talking about a network segment, an IP network segment. And these terms, prefix and network, from a routing table perspective, can be used interchangeably. So let's go ahead as an example and pick on this one specific route right here. So this route points to the 172.16.6.0/26 network. And just as all these 10 networks were under this heading of 10.0.0.8 because it's a Class A address, here we have this heading of 172.16.00/16 because the first octet of 172 means it's a Class B address, and then below it, it's indicating all the subnets. So for this one route, the network is 172.16.6.0, just as it appears, /26. Now, I've got a question for you. What would that mask be, just for grins, what would that mask be in dotted decimal? So if we went 2 bits further into this last octet, what would the mask?
Sneak attack. I'm going to ask you to do this. Think about this. So if you're brand new to IP, you don't know about subnetting yet, you're excused from this exercise, but if you have a familiarity with masks or you've been through some of the training on it, I'd like you to take a moment right now and identify in dotted decimal that last octet for the mask for a /26. What would it be? I'll give you 3 choices. 128, 192, or 224. It's one of those 3. If you type that in as your answer, and I will go ahead and resume the video here in just a few moments. All right, I couldn't resist a little bit of that specific music for for my own pleasure. All right, so hopefully You provided your estimations, and let's go ahead and continue the video. And this is the kind of interaction I would also recommend as we're going through the videos together. Once these are all released on the CPT Nugget site, or you're watching on mobile, what have you, is that whenever I ask a question, pause. If I ask you to do a lab, pause, do the lab, do the hands-on, and that way we're both going to benefit from the experience. I want you to get every ounce of benefit that you possibly can out of this training, because that will turn into skills and knowledge, and then when you get it applied to the work experience, it becomes more and more valuable to you and your family and your employer and everyone else. So I'm going to hit resume, and let's take a look at the answer.
B, in that last octet, to represent a 26-bit mask. And if you're fairly new to that process, one of the techniques I strongly recommend is just putting the numbers up here: 128, 64, 32, 16, 8, 4, 2, 1. Also, you can start from the right and just go 1, 2, 4, 8 and double it. So 24 bits is up to this point. If we had two more, that'd be this one and this one for the mask, and all the rest would be zeros. And then we just add those up. So 128 plus 64 equals 192. So the mask in dotted decimal would be 192. So if this router received a packet that was destined for 172.16.6. All right, so this is where it gets a little bit interesting. Because if I want to have a host that has an address in that subnet, I have to know what the range of that subnet is. So if I did a quick calculation, the block size for the subnets is going to be 64. So because the block size is a 64, that would mean subnet would be 172.16.6.64. So I'd want to make sure I had a host address on that real subnet. So if a packet came in and was going to 172.16.6 dot, and let's put 50, that's perfect. The router would look at that destination IP address and say, well, my match is right here. This is the route. And as a result, it would go ahead and use 10.12.0.2 as its next hop, and its exit interface, its egress interface, would be gigabit 1/0. And it would forward that packet on to router 2, and then it would be R2's problem to process that packet and to continue forwarding it in the right direction. In this video, we've taken a look at the routing table with a focus on the network portion along with the mask included in individual routes. I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.
All right, and as these videos continue, the next one would be the next hop, and then administrative distance, and the routing table metric, and the gateway of last resort, and so forth and so on. And hey, I wore the appropriate shirt for today. I didn't realize we were going to do any kind of... anyway, here's my binary shirt. Love it. A lot of fun. All right, also, just as a heads up, this content will come in a playlist where the learners, and you and I would already have the experience of going through network basics, like how does switching work and how do trunking work and what is an IP address and how to do subnet masking and the basics of all that. And now as we get into routing, we're reinforcing that or revisiting that because, you know, if you're a router or if we're a router and we get a packet, the way that router looks and identifies the longest match based on a packet coming in is the route he's going to choose. And sometimes you have to go back to our subnetting skills to identify, oh, well, you know, I've got 5 subnets here in my routing table. Which IP address does this fall into? That's yet another reason to, you know, brush up and become pretty good at IP subnetting. So I got feedback from Jake and from Josh regarding what your comments were earlier. It looks like we have an overwhelming majority for OSPF next Wednesday, 6 p.m. Pacific time, that's what we'll do. I love OSPF. Let me tell you, when I first learned... a long, long time ago, in a galaxy far away, I was a CCIE in 2001. That's when I got my first one. And so as part of that, what I did was I didn't have any access to virtual gear, so I bought routers, I bought switch. Well, in those days, I bought routers, I bought switches, and I bought a token ring switch. Boom. Anyway, and I racked them all up in my house, and I vented it out the top of the house so that with an exhaust fan, so the heat would be maintained. Where was I going with all that? Oh, OSPF, right. So I learned all the basics, like a lot of things, data link switching and OSPF and RIP and EIGRP and et cetera, et cetera. But every time I have a chance to come back and revisit it, which is like every 2 to 3 years, hey, there's a new CCNA. Oh, hey, we're going to do professional level training. Oh, hey, we're teaching Juniper with OSPF. Or every time I visit it, I swear, I I learned things I didn't realize before about that protocol. And maybe it's because I forgot some of it, but most likely because I have a comfort level with it. And that's true with our videos too. So if you go back and watch something for the first time, and then you give it a rest, and you come back and watch it again, maybe do some hands-on labs, and reinforce that, you're going to pick up new things almost every time. So with OSPF, oh my gosh. With OSPF, it's a link state routing protocol. And with a link state routing protocol, it's like having two routers that have an agreement. Like, hey, buddy, how you doing? Like, let's say you and I are OSPF routers, and we have an agreement. Part of our agreement is, hey, I'm going to say hello every so many seconds to you, every 10 seconds or something. I'm going to say hello, and I'm going to see your hellos, and we're going to make sure that you're still there and you're good and everything else is fine. And we're also going to agree as neighbors on what is the common network segment between us, and what is the security between us, and all these other parameters that are required for us to become neighbors. But once we become neighbors and we're sharing information with other OSPF routers with a thing called an LSA, which is a link state advertisement, which is pretty darn cool. Now for CCNA, we only need to worry about two types, type 1 and a type 2. We'll cover other LSA types at the professional level. But when that relationship gets established based on the type of network, there's a lot of really cool magic. And it's not magic, but there's a lot of cool things that happen with an Ethernet segment versus a point-to-point. And I remember struggling like back in 2001 or 2000, I guess it was my CCNP studies, maybe 2000-ish, 1999, with some of those topics. And now, because I've had the opportunity to work with them many, many times, also in production environments with OSPF and routing protocols, I can take the concept and like what really matters. Like what is the most important aspect of this as far as implementing it and troubleshooting it, and teach that at the CCNA level, while at the same time realizing, oh, there's another world out here with more information, but we'll take that one step at a time. So I had so much fun. I have a confession to make. Here it is. I think only one other person knows this, and now everybody will. I was creating a skill on OSPF, and I wanted to be very concise and very thorough, and it turned out that it was going to be too long, right? I was going to have too many videos to do everything and the labs. And so to solve that, because I don't want to have one skill that's like, 15 or 20 videos long. It's too long. We want to make nice and tight containers. So what I did was I talked to the team at CBT, and I said, it was Matt. We have a guy named Matt, M-A-T, 1T. And we call him Matt 1T, or maybe just 1T. Anyway, I asked him, what do we do? I'm early on, and it's going to be too many. And the idea we came up with was, well, have one skill on understanding OSPF. And that way you can focus on the concepts, the neighborships, how to configure the basics of it, and so forth. Just on the fundamentals, like the concepts and ideas, and some hands-on labs to reinforce those ideas, like designated routers and backup designated routers and DR others and everything else. So it was fantastic. So I built labs for all that, and then we switch over to implementing OSPF, where we focus on the implementation and verification of OSPF. And then for the finale, what we do is we apply all those skills. It's like training wheels. We do small networks first, and then as we build the skill, then we apply it to what I call the production network, which is the our master CCNA topology, which rocks. It's a lot of fun. So yeah, the benefit of all those pieces. I wanted to keep this moderately short to be respectful of your time. I really appreciate everybody who came live. I know a lot of people enjoy watching this after the fact. It's recorded. Being here live means a lot to me because I know I'm not alone. So it's like I'm alone in a room. Hey, you want to hear one more story? I'm going to tell you another story that's a little embarrassing and fun, though. Fun, and it's short. I won't tell you the company, and I won't tell you the exact time because it was somewhere between 9 and 15 years ago. So somewhere in that swath, you can look at my history and find out where I was. But I was teaching an online class, and they wanted it for the recording. So they wanted me to teach this class on topic X, and they were going to record it. And they didn't sell any seats, meaning they didn't try to sell any seats. They were just going to have me record it. And then they thought, oh no, if Keith is teaching and he thinks nobody's in class, he's not going to have his, hey, how you doing? And personal. Anyway, I was ready to do that, by the way. I was ready to teach just like this. Well, you're live and I'm live. But I'm prepared to teach to an audience that's going to be in the future. We do it all the day with CBT Nuggets. Anyway, long story short, they put 5 fake seats in the class. They had 5 people from the company, log in and just leave it, mute it, shut it, in the background. And so I started teaching this class not knowing that everybody in the 5 people in the class were not real. And so I started interacting or trying to interact with these students, like, okay, what is the like we just did? What is the dotted decimal mask for a /26, or what is the range for this subnet or whatever? And I was getting crickets, nothing, no one responded. And so during my first break, I contacted the powers that be and said, hey, I've got a problem. I think everybody's dead or something. There's no one is responding, not a comment, not a peep. And then they told me, oh yeah, we those aren't real students. I was like, what? Anyway, they corrected it. They pulled them all out. And then the benefit is that, and this is the benefit of CBT too, as I teach in this studio here in Las Vegas, which is where I do most of my recordings, is that I can take the time to get it right. Like if I have a little slip up or I type something and it's like, oh, fumble fingered, I may leave that in because it's very human, right? It's like, that's what humans do. We sometimes make a little mistake. But if like today, I was recording today on the control plane and the data plane and the data plane and the management plane on network devices. So I found a clever way to explain it, a clever way to describe it that made sense so that somebody watching this for a few minutes would say, oh yeah, I get it. And then examples of it. Well, I was doing a video and I recorded half of it and then realized, hit the button for stop record and thought, you know what? I'm going to do that whole thing over with a slightly different angle. And so I can do 2 or 3 takes or 4 takes. A lot of times it works like this though. 1 take. And that's because I do a lot of prep work before. So I sit down with the topic and I write out what's the core thing. What is it that I want you to walk away with knowledge-wise after we have our time together in this video? And I'm very clear on that. And that's my primary. And then I spend a lot of time labbing it up, practicing it, rehearsing how it's going to go. And then when I go live, I hit record, I'm talking like I am to you right now. So a lot of times people will come to me and say at Cisco Live or other place. In fact, I had somebody in an elevator say, hey, you sound a lot like Keith Barker. Yeah, I get that a lot. My one of my kids was at a store and she had some CBT Nuggets paraphernalia on, like a hat, I think. And anyway, somebody stopped her and said, hey, do you know Keith Barker? And she's like, yeah, that's my dad. And anyway, it's pretty cool. I love the relationship that I have. I do. I love the relationship. I had a learner out a couple weeks ago, and I hope I can say his name. It's Gus. I did it. So I love meeting people when they come to Vegas. I will always make time when possible to say hello, have a bite to eat, give you recommendations what to do here in Vegas. But I am in a love affair with my students. I say my students. I feel pretty personal about having you in my classes. So it means a lot to me that you're joining me in these live streams. Hopefully, the time that we invest together, whether it's on this channel or training videos or some other place in the future, I want to make sure I'm providing value. At the end of the day, I want you to have more, come out a better, more valuable than we started. So everybody I touch, I want them to walk away saying, you know what? Yeah, I'm better now. I can, if it's technical skills, great. I can read a routing table. I can walk into a production environment. I can configure OSPF, IPv6, static routes, OSPF, etc., and increase our value all the time. So anyway, wow, that was a little Keith Barker soapbox. I am very grateful. Next week, same bat time, same bat channel, 6 p.m. Pacific. We will cover OSPF. We'll look at, I will hand pick a few of the videos from the 2 OSPF collections that I have, one on concepts, one on implementation, and I'll carve them out so that you can enjoy them. Also, I know many of you have already subscribed, so you get alerts and so forth for live streams and new updates. If you haven't, please do so. If you have a friend or two that is interested in IT or CCNA or just wants to see, hey, is this something I could do? The answer is yes. Most people can get into IT. And turn them to this channel. This is a community of support for anybody who wants to get better at IT. And I've been around the block almost twice, and I still love it. And guess what? I still have to, and I get up every day and realize today is a day that I get to learn something new or reinforce something or keep moving. Because the moment we say, oh yeah, I know everything I need to know, that's not a good day. So I'm in the same boat, whether you're just starting in IT or you've been there for 10 years or you're an old original gangster of IT like myself. I'm in for the long haul. So I'm going to close it off by finding some really fun music. Let me look that up real quick. And, oh, there's some fun music. And let's do this is called Gears of Steel. Somebody asked in the previous stream, they said, Keith, where do you get the music? Music is interesting on YouTube. So I have a subscription that, what is it called? Epic Music? Anyway, where they have a library that I can use for my content on YouTube. But also, I've often used in the past, I still do, have a license for Camtasia by TechSmith, which is fantastic. And they have a free library. They have a library of free music, and they also have some additional music you can pay for. And then currently in my processing, I use some Camtasia, and I also use Adobe Premiere, which I've recently moved to more predominantly, but still have licenses for the other as well. So I get those questions a lot, so I wanted to answer them. And I'm going to do a little sign off here with Gears of Steel. Thanks, everybody.